Hey guys, welcome back to my channel, and today we're going to continue with the second video for limits, which are basically just limit problems like I discussed before in our limit video. So for limit problems, I'm going to start with one of the problems that you'll commonly see in a lot of your math classes, especially involved with limits. So the first problem is the limit. So we're going to have some conditions first. So we're going to say the limit as x goes to 2, f of x equals 4. Okay, and then we're given another condition that the limit of x goes to 2g of x is equal to negative 3. And lastly, we're going to give one more, which is a limit as x goes to 2, h of x, which is equal to 0. Okay, so now based on this, we're going to be given some problems. So first problem A, let's say, find the limit, I'm sorry about that. Find the limit as x goes to 2 for f of x plus 5g of x. Okay. All right. So using our limit laws that we learned before, we have f of x and we have 5 times the g of x. And since x is going to 2, these are also x going to 2, so we have no worries. So we have a 4 here and we have a negative 3 for f of x and g of x. We do basically, it's really simple. We just do 4 plus 5 and then negative 3. So when you're plugging in these values, you have to get rid of this limit x of 2. You can't include that. So you can't write limit x of 2, 4 plus 5 to the negative 3 because you plugged it in, so it's done. So now, after that, and the reason why this works is because, remember, in limit laws, you can split the addition. So you can do this part, and then you can do the limit of x goes to 2, 5g of x, and then you bring out the constant in the front. But that just takes too much time, so it's easy if you just plug them in. So 4 plus 5, negative 3, which is 4, minus 15, which is negative 11. Okay? All right, let's go to the next problem. All right, I'm just going to clear it so that way we have space. And all right, the next problem is same thing, except it is the g. It's a little bit different. It's g of x squared. And remember, when we're talking about powers, remember we do it to the whole thing. So it's like the limit as x goes to 2, g of x squared. And then that equals negative 3. And then we square that, which equals 9. Kind of easy, right? So I'm actually going to probably not leave this up. So I'm going to make sure, probably write this down of some sort to the side. Or actually I'll just leave it out. I'm just going to erase though, okay? Alrighty. Okay, let's do the next one. So it's the same thing except it's a different type of problem. Alright. Okay, so now we have let's say we have another problem here. Instead of this, we have the limit as x goes to 2, square root f of x, right? And remember, oops, mom said, sorry about that, f of x. So it's the same thing, except you can now apply the square root to the whole thing as we talked about in limit laws. So it can be like this. This goes to 2 f of x, and then limit of 2 f of x we already know is 4, and so the square root of 4 would equal 2. So our answer would be 2 for this one. Okay. Alright, and then let's see. Our next problem is actually a little more okay, so our next problem is a little more easier, but you just need to be able to identify why it's easy. So yeah, the limit as x goes to 2, f of x over g of x. Now f of x over g of x, okay, this one's actually pretty straightforward since the most simpler one. So remember, you can apply this limit to the top and bottom when you have a division, so it would be the limit of f of x over the limit of g of x, but I'm not going to write that out, so that's just 4 over negative 3, or negative 4/3. Okay? Alright, and then the next one is the limit of 2g of x over h of x. But before we actually solve this problem, it's the same division like we did last time. You can do the limit of g of x over the limit of h of x. H of x equals 0, so that means our denominator would equal 0, so therefore this would automatically does not exist, because you cannot have a denominator of 0. Okay, and then our last problem is g of x times h of x, and then over f of x. And this one was actually pretty straightforward too, because if you think about it, it's basically doing the limit of g of x times the limit of h of x over the limit of f of x, right? And since h of x is 0, that means 0 times any number here would equal 0, so it'd be 0. Your final answer would have to be 0. Okay, so those are for these problems. Now we're going to do some that's a little more different, but they're the same process. So let's start with number 1. We have the limit as x goes to 5, x squared minus 6x plus 5 over x minus 5. Okay, so there's this thing. If you plug in, so the way limits work is that you plug in this value and you try to find what it would equal. But let's say it gives you a value of 0 over 0. That means that you have to make sure that you simplify before you plug in. So when you actually plug in 5 on the top and bottom, you actually get this situation of 0 over 0. That means, okay, it's not undefined because it's not a number over 0, so therefore we have to simplify. So that's what we're going to do first to make it easy. Best way is to always simplify first. Always simplify when you're working with limits. So you have 5, 1, so I'm basically, factoring it. So then after that I would have minus because it's x squared minus 6x plus 5. And then I have x minus 5, and then all of this, obviously you need to make sure you include the limit part of this because you haven't substituted anything yet. So then this would cancel, and you would only be left with this part here. And now, if I plug in 5, you have 5 minus 1, which equals 4, so my answer would have to be 4 for this one. So whenever you're working with limit, the best way is to simplify first before you plug in anything. But if you're unsure if you have to simplify or not, you can plug in the number. If you get 0 over 0, then that means you have to simplify. Okay, let's do the next problem. So we have the limit as x goes to negative 2, and then we have x plus 2, and then we have x cubed over plus 8, I believe. So here, when I actually plug in negative 2, I get the situation of 0 over 0. So that means I'll have to simplify this as well. So most likely the denominator is going to be simplified. So that's what we're going to do here. So we have an x plus 2 most likely because it's probably going to cancel. And then we're going to have some situation where it's going to be like x squared. And then we have 4, right? And then we should have some number in between, right? So we have x squared and then probably something that subtracts so that way it cancels. So probably 2x, like that. Because I have x squared, then I have minus 2x plus 2x squared, which cancels. Then I have 4x minus 4x, which cancels, and I'll be left with 8. Now if I cancel this, I'm left with 1 over this part right here, just this part. Okay? And then I can plug in negative 2. So if I plug in negative 2, I'm going to get 1 over 4 plus 4 plus 4, which is 1 over 12 as our answer for the limit. Okay, the next one, limit as x goes to 3, 1 over x minus 1 over 3 over x minus 3. And remember, I told you the best way to solve these problems is to always simplify because that's the straightforward way to do it. And looking from this, you're going to get a 0 over 0 situation. So best way is to just simplify. So I'm going to make a common denominator and solve. So I'll get 3x. Okay. And then out here, I'm going to get 3 minus, and then I'm going to have x on the top for the numerator once I have a common denominator, because it's 3 over 3x, which is 1 over x minus 1 over 3. And then I have x minus 3. And then I can use the idea of keep, change, flip. And when I do that, I'm going to pretend this is x, and I'm going to do x minus 3. I'm going to rewrite it like this to make it easy. 3 over x, and then I'm going to have and then I'm going to have 1 over x minus 3 is what I'm going to eventually be left with. And then I can cancel these, and then remember you have to have a limit of x in the front because you haven't substituted anything yet, you're just canceling. And then we're going to be left with negative 1 over 3x, and then when I plug it in, I have 1 over 9, because 3 times 3 is 9. Okay, we have 2 more problems, and then after that, we're good. So this problem is actually the most easiest one. So we have limit as x goes to 3, 5x cubed minus 3x squared. So this one, you don't really have any canceling to do or anything like that, so it's normal, just plug in, which is the most easiest problem you'll see. So I just plug in, so 5, and then 3 times 3 times 3, which is 27, minus 3, and then 3 squared, which is 9. And then when I multiply 27 times 5, I am going to get, so 5 times 7 is 35, so I get 135 minus 27, and that's going to leave me with 108 as my answer. So this one's the most easiest because it's just direct substitution. Okay, and then lastly, we're going to do one more problem. So limit as x goes to 5, x squared minus 5x plus 6 over x minus 5. So looking at this, when I just plug in, right? Let's plug in. Let's make it easy. So we get 5 squared, we get 25 minus 25 plus 6 over 0. So we actually get a 6 over 0 situation, which is undefined. It's not 0 over 0. It's a number over 0. So if you get this type of situation, off the bat, we know this is undefined, which also means that it does not exist. This limit does not exist because it is undefined. Alright, so thanks for watching. If you have any questions, please put them down below. Please comment, and thank you so much, and bye.